In the last two lectures, we have learned about the fundamentals of welding and the type of welding processes. In the first type, we have learned about the fusion welding process, and we have already discussed the electric arc welding in its type. Now, in this lecture, we will learn about the oxy-fuel gas welding and resistance welding in its type, and the high energy beam welding. Fuel gas welding, resistant welding, types of resistant welding, and the high energy beam welding processes. We will discuss about these three welding process. These three also are also the type of the fusion welding process, but all the three process welding processes are distinguished with each other. In oxy-fuel gas welding, is generally is a general term used to describe any welding process that uses a fuel gas combined with the oxygen to produce a flame. This fuel gas, it could be any gas, it could be mixture of gases, that is air, it could be any organic gas. In this type of welding, oxy-fuel welding, we will use oxygen to burn the other fuel gases. The most common gas uh, is which is normally used in this oxy-fuel gas welding is the acetylene gas. Acetylene gas is the very unstable gas in the when it is in a pure state, and it is very reactive. It is a very good reaction, or it has a very good reactive properties with the oxygen. During this welding process, when this gas fuel gas is react with the oxygen gas is used to produce combustion, or used to combust the fuel gas, and result of combustion, the flame will produce, and that flame is the source of the heat that is used to melt the base metals and form a strong joint. This is a two-stage process. Like this welding perform in two stages. In first stage, acetylene gas will react with the oxygen gas, or oxygen gas is meaning the pure state, and these two gases are stored in these two cylinders. The red one represent the acetylene gas cylinder, and this one represent the oxygen gas cylinder. And above both cylinders there are regulators or pressure regulators. They are used to regulate the pressures of both the gases. There's one welding torch, as you can see. This process or this welding process occurred in two stages. Number one, acetylene react with the oxygen. In the first stage, carbon monoxide gas and hydrogen gas will form, and in the result, the 448 kilojoules per mole heat will produce in the first stage. And in the second stage, this produced mixture of carbon monoxide and hydrogen gas is further reacted with the 1.5 mole of oxygen, and in the result, carbon dioxide and water vapors will produce with the liberation of 848 kilojoule per mole heat. If we combine the heat of both the liberated heat of both these stages, and if we study in joule per meter cube unit, it is 55 into 10 is to power 6 joule per meter cube, and this heat is used to fuse base metal. What exactly happen in this, or what exactly happens in this welding process? This is a welding torch. In welding torch there is one mixing chamber, and in mixing chamber there is one tip, um and there is two pathways of both the gases. One is for oxygen, other one is for acetylene. The two hoses are connected to one another. One hose is connected to the blue hose is connected to the torch from one end, and the other hose is connected to the other end of the welding torch. There are two valves, blue and red, as you can see on the torch. Here is also, you can see, are provided. to this welding torch, which are used to regulate the flow of both the gases. Both the gases will pass through the mixing chamber, and in this chamber, these two gases will mix together, and this tip is only used to direct the mixture of both the gases. And when the mixture of both the gases will come out from this tip and it will in contact with the base metal, the l- huge flame or the large flame will produce, because the oxygen gas is used to burn the acetylene gas, and due to this burning or due to combustion, flame will produce, and this flame is the source of heat, and that heat is used to melt the base metal. And along with the base metal, this filler rod will also melt will also melt, because when the filler metal is used, it is typically in the form of a rod with diameter ranging from 1.6 to 9.5 mm, and composition of the filler must be similar to that of the base metal, because if the temperature or if the melting point of the filler metal is greater than the base metal, then it will not melt during the welding process. So the composition of the filler metal must be similar to that of the base metal. The filler metal is often coated with a flux that helps to clean the surfaces and prevent oxidation, thus, and therefore creating a better weld joint. This during the welding, when the acetylene, as you know, acetylene is the most popular fuel uh, in the oxy-fuel welding, because it is capable of high temperature than any of the other gases. The temperature will go around 3500 degrees centigrade or 3480 degrees centigrade. And it is a two-stage process. The two stages are visible in the oxyacetylene flame, as I have explained you before. In the page 7, as you can see, there is a chemical reaction. A neutral flame will form during the combustion, and this neutral flame consists of two cones. The first will consist of the inner cone, other one is consist of the outer envelope. It is also called the blue flame. This blue flame, and the temperature of blue flame is around 2500 degrees centigrade in middle of the flame, and outer of this at this tip is just around 1000 degrees centigrade. This flame is only used to preheat the base metal. It is used to preheat the base metal or to prepare the base metal uh, for welding base metal. And this inner cone used to fuse the used to fuse the base metal, or to bring the base metal into the molten state. Temperature of this inner cone is around 28 degrees centigrade to 3500 degrees centigrade, and it is which is a very huge temperature to melt any base metal. And this flame is called neutral flame, and it is used to weld ferrous and non-ferrous. This welding, after getting the understanding of the oxy-fuel gas welding, we will discuss about the resistance welding. Resistance welding comes in the group of fusion welding operation, or it is a type of fusion welding process. In this type of welding, the joining of the two metals is done with the combination of the heat and pressure. Heat is generated in this type of welding by means of the electrical resistance to the current flow across the part. I will explain this thing which I have said with the help of this picture. Actually, in resistance welding setup, there are two electrodes, and under these two electrodes, there are two base metals. The base metals come in contact with each other. Normally, lap joints are formed with the help of the resistance welding. These two electrodes are connected with the transformer, and two base metal are placed over the surface of the fixed electrode. This is fixed electrode, and this is movable electrode, and both electrodes are connected with the transformer. This is primary winding and this is secondary winding. When movable electrodes come in contact with the surface of with the base metal surface, by virtue of the force F, this force F will create a mechanical pressure over the surface of the base metal, and this mechanical pressure is required during the welding. When the movable electrode come in contact with the base metal, the current will flow from transformer, and it will go towards and it will move towards the movable electrode. From movable electrode, it passes to the or it enters into the base metal, and at the junction of the base metal, when the current enters, this current will create electrical resistance. This electrical resistance will increase the temperature, and that temperature is responsible to generate heat, and this heat will require to melt this base metal which is in contact with the electrode. Eh, only this part is melted which is in contact with the electrode. When the base metals are melted, the electrical current will turn off, and force is applied to join both the base metal surfaces which is in molten state. And due to this force F, mechanical pressure will generate, and this mechanical pressure will complete the formation of weld joint. This orange part represents the molten metal, and after the application of the forces, the two molten parts will fuse together or will fuse together and form a weld joint. Normally, the current duration during the resistance welding is from zero point 0.1 second to zero point 0.4 seconds. This is very less time. And solidification time, or the time when the force is applied or the force hold this base metal, is from 1 second to 4 seconds. This resistance welding has three types: spot welding, seam welding, and projection welding. First, I will explain about the spot welding. Spot welding, it is a type of the resistance welding which is used to join the two metals with the combination of the heat and pressure. Normally, rocker arm spot welding machine is used to perform this operation. Uh, in this machine, there are two horns, upper horn and lower horn. In lower horn, one electrode is fixed and the upper horn is movable. And in upper horn, there's one electrode is placed, and that upper arm is connected to the rocker arm, and rocker arm is connected to the pneumatic actuator, and pneumatic actuator is directly connected to this pedal. The spot welding is normally performed in 5 steps. In first step, only base metal are placed over the surface of the fixed electrode, and the second steps, operator press the pedal and air is flow into the pneumatic actuator. Pneumatic actuator is actuated and generated a force, and that force is transmitted towards the movable electrode through the rocker arm. When the movable electrode comes in contact with the base metal in step 2, force F is responsible for the generation of the mechanical pressure over the surface of the base metal. In step 3, when the electrode comes in contact with the base metal, the transformer will turn on, or electrical current is flow towards the movable electrode. Electrical current passes through the movable electrode and it enters into the base metal. When it enters into the base metal, due to high electrical resistivity, both the base metal should have high resistivity, and high resistivity means low thermal conductivity or low electrical conductivity, and both the base metal should have low melting point. This is the prerequisite for spot welding. These are the three prerequisite for uh, spot welding. The base metals which are going to be welded should have high resistivity, low thermal conductivity, low electrical conductivity, and low melting point. And due to high resistivity, the temperature between the melting surface of the base metal will increase, and due to increase in temperature, heat will produce, and that generated heat is responsible to melt the fang surfaces or melting surfaces of the base metal. When the base metal is melted, the current will turn off and force will hold the base metal, and due to this force mechanical pressure will generate, and that pressure will complete the formation of welded joint. And the welded joint will call, this is the welded joint, blue color is the welded joint, this welded joint will call welt nugget in spot welding. If you see in step 4, the solidification of the joint is done, and in step 5, movable electrode will move upward and we will remove this lap joint is formed in step 5 finally. And if you see, you will see one spot over the surface of the upper part of the lap joint, and you can see one spot uh, over the surface of the, or or on the lower surface of the other part of the base metal. And if you cut these lap joint, I will show this is front view. If you cut the base metal, you will see this nugget inside the lap joint. This is the weld nugget, and this weld nugget has dimensions 6 mm to 15 mm in diameter. The current in spot welding ranges from 3000 ampere to 40,000 ampere, because current will be dependent. The current depends upon the type of material which are going to be welded and their thickness, because geometry is most important in spot welding. If you have high thickness, the more current will be drawn from the transformer. For example, to weld the sheet metal parts, which is made up of stainless steel or the pure steel or cast iron, 10,000 ampere is required to weld them, to perform the spot welding. And if you have a sheet metal parts which are made up of aluminum alloy, then 13,000 ampere is required for spot welding. You can see here these 5 steps are plotted in graph. There's one graph, and we call it the plot of skew force and the electrical current. In first step, as you see, there is nothing, no lines are drawn in step 1, because only lap joint placed over the surface of the fixed electrode. In second part, force will apply, as you can see, from 0 to the force will increase to certain value, and it will remain constant to the end of the step 4. In step 3, current will turn on, as you can see, from 0 to, it will go to some value, and it will remain constant at the end of, or till the end of the step 3. There is one dotted line, it is also representing the current, because sometimes we need extra current to form a proper weld nugget, because sometimes there are certain metals like copper. Copper is extra current is required to melt the copper parts or copper alloy sheets to form a proper joint. So this small dotted lines will represent the extra current required in spot welding. The heat is generated by the electric, or the heat energy generated by the H is the heat energy generated by the welding process, or this is the heat energy which is generated by the electrical current, and this heat energy H will not completely use for welding. There's one portion called HM will be used for welding. This is the part, this HM is the part of H. H is the total heat energy generated by the welding operation or welding process. But HM is the net heat required for welding, or it is required for melting the base metal, which and that HM is less than H. The value of HM is less than H, and this is the equation of the heat energy generated by the welding operation. I square RT. I is the electrical current drawn from the transformer, and R is the electrical resistance due to the current flow, or due to the current flow of current, and T is the time length, or the time uh, during the current is flowing um, through the electrode, and normally it ranges from zero point 0.1 to zero point 0.4 seconds. And this equation will apply it in solving the numericals portion of the spot welding. One more thing I will explain: this HM is equal to UM and V, product of UMV. U is the unit melting energy, and it is the energy which is used to melt the base metal per unit volume of the base metal, and V is the total volume of the melted metal. The unit of V is mm cube or inches cube, and has unit of joule per cube, and HM is a unit has unit J joule. There is a second type of the resistance welding, which is called seam welding. Seam welding, it is a modified form of spot welding. In spot welding, you can see a stick shape. This stick shape electrodes are normally used, and the tip of these electrodes can be round, triangular, even rectangular, hexagonal tips can be used in stick shape electrodes. But in seam welding, because it is a modified form, the spot welding, all the phenomena or operation or process are same as it is done in the spot welding. But there's slight change: the electrodes, the stick type electrodes, are replaced by the rollers or the rotating wheels. Both rotating wheels rotates in the opposite direction. One rotates in the anti-clockwise direction, other rotate in the clockwise direction. uh, this is the type of this is also a type of seam welding. It is called intermittent motion welding, or intermittent motion seam welding. This is the continuous motion seam welding type of continuous motion seam welding. um, what happens exactly, or how this seam welding is performed: these two electrodes are connected with the transformer, and electrical current will flow from this electrode into the base metal, and from base metal into the other part of the electrode. These base metal will move, or will travel from right to left, or left to right. It depends upon the rotation of the wheel. If upper wheel rotating anti-clockwise, then base metal will move from right to left, and if the upper electrode is rotating in the clockwise direction, then the base metal will move from left to right. During the seam welding, a proper seam or proper joint will form, and in intermittent motion welding, spots will form. These spot will form in this type of welding. uh, Periodic current will apply, or at the position of periodic current will apply at the position of the spots. And in all type of weldings, these rotating wheels rotates in uh, will rotate continuously with uniform velocity. In third type of resistance welding, which is called projection welding, it is also a modified form, the spot welding, but there is a slight change of electrode. In projection welding, rectangular electrodes will be used, but with projections are present in the electrodes. As you can see, the three projections are present in the electrode, and due to high electrical resistance at the joint, these electrodes will come in contact with the base metal, and due to these projections, spots are formed over the surface of the base metal. All the phenomena will be same as it is done in the spot welding, but due to change in electrodes, there will be a new, or there is a new welding type called projection welding. Why it is called projection? This is the electrode and these are the projections. It could be more than three or it could be less than three, but sometimes it will be 15 in one electrodes. It depends upon how many spots we required over the surface of the base metal. And this is the same phenomenon which I have explained in the spot welding. This is the transformer. This is secondary winding. This is primary winding. Current flows in this direction. Electrode come in contact with the base metal, and due to these projections, as you can see, there are three projections. Three spots are formed, and then current will return into the or will go back into the transformer. This is the closed circuit. Closed circuit is formed during the welding. This is a movable electrode, and this is a fixed electrode. Base metals are placed over the surface of the fixed electrode. For precision welding, spot welding equipment can be used, but we have to remove the stick shaped cylindrical electrodes with this projection type electrodes. You can use the same rocker arm machine for this projection welding, but you have to replace the electrodes with the projection electrodes. You can weld large thickness parts like more than 12.7 mm. Sheet metal parts can be welded with the help of the precision welding. 15 to 16 mm normally thickness sheets can be welded by precision weldings. This projection welding are normally used to weld this grills, window grills can be welded. Y- you can see sometimes there are some sheets on which bolt or screws are welded permanently. So for this permanent joint is projection welding to permanently join the bolt with the sheet. This projection welding will be used, and there's one nut which is permanently welded into the sheet. You can see these three types are most commonly used, or these three are the most common application of the projection welding. Spot welding are highly used in. I will go back to the spot welding. Spot welding application are highly used in automobile industry. In normally in Honda, Atlas Honda bike assemblies or bike frame are spot welded. Are usually spot welded. Spot welding has a very big application in making the frame of the aerospace or the airplane bodies. uh, Boeing, Airbus are using this spot welding technology. Medical equipments like CT scan, MRI beds or handles are welded with the help of spot welding process. And this resistance welding has great importance in industrial application. Uh, After studying resistance welding and its types, we will study about the uh, energy beam welding. Energy beam welding has two types: electron beam welding and plasma beam welding. In electron beam welding, uh, it is a type of the fusion welding in which high energy electron beam is used to weld the parts. Uh, in this process, the high energy electron beam kinetic energy is converted into heat energy, and that heat energy is used to fuse base metal or for welding purpose, for welding process. This process or this welding type required a very delicate apparatus, as you can see in the picture. On the top of the apparatus, there is one cathode, and this cathode is connected to the power supply, and through power supply, electric current supplied to the cathode. This cathode is made up of the tungsten electrode, and tungsten has a high melting point, and due to electric current, this filament will heat up to 25 degrees centigrade for continuous emission of the electron beam. Electron beam consists of the electrons. Electron is the charge, and for the moment of charge, we need a potential difference. So, primary anode is used and in the apparatus, which is required for the moment of electron, and it accelerates the electron from a electron jet. Actually, beam is also called a jet, which is moving with the very high velocity. So this anode is only accelerates the electron beam towards the vacuum chamber where the workpiece is placed. Where the workpiece is placed. Moreover, this high jet of electrons strikes on the workpiece or strikes in the weld cavity. This apparatus or this unit directs high velocity electron beam to the weld cavity where its kinetic energy converted into the heat energy due to collision with the workpiece. This energy is required to create weld by fusion. Actually, in this type of welding, very delicate and very fine weld joint will produce, and no filler material, no flux will be used in this type of welding. This is the advantage of this welding, and that's why this welding is not so much costly, or this operation is not so much costly. Although this apparatus is very costly, initial cost of this welding is very high because due to expenses of this apparatus, which is a delicate and a special apparatus. And there is one telescope is provided which you, and through this telescope you can view the welding process through this telescope. And there is one you can see there is one magnetic lens, and this magnetic lens absorb low energy electron, and it doesn't allow to diverge electron to pass through it. If electron beam diverge, it will scattered somewhere in the apparatus, and you will not get a proper joint, because it is very important to convert the beam into the weld cavity for proper welding. So this magnetic lens will use, and this deflection coil and focus coil both have the same mechanism, because one focus coil will be thick in nature, because as you can see here, the beam is broad in nature. There's some width in beam, and this deflection coil, it will keep the beam to direct into the weld cavity. This type of welding can you can weld different types of part from foil, which has very less thickness, to the large part. You can weld variety of parts from thin to thick parts. For thick parts or for thin parts, the voltage range of power supply is 5,000 kilovolt to 30,000 kilovolts, and for thick parts it will be 50 kilowatt to 120 kilowatts. Actually it is 120 kilowatt, 120 kilowatt for thick parts, because for the thick parts you need a high current and you need a high source or high voltage. This type of welding is used in the aerospace and marine industry. And there is one disadvantage, your vacuum chamber. You can only place a workpiece which is less in size as compared to the vacuum chamber. If your workpiece is greater than the size of vacuum chamber, you cannot weld those parts. And one more thing, vacuum will be created inside this chamber with the help of the mechanical pump or electrical pump, because vacuum is needed to prevent this part or prevent this electron beam from the outside atmosphere or outside environment. This is all up to the for this is all for the electron beam welding. And you can see application of this electron beam welding in automobile industry. You can weld different types of gears on the shaft. Normally Ferrari is using this electron beam welding to make their differential box. And you can weld titanium alloys with the help of these parts. With the help of this welding, you can weld titanium alloys with the help of electron beam welding. And one more thing, the chamber or vacuum will be created through mechanical or electrical pump. In the next type, we will study about the plasma arc, laser beam welding. Now I will explain you about the laser beam welding. Laser beam welding, it is also the type of the fusion welding, and it is also type of energy high energy beam welding. Laser beam is the welding technique used to join the multiple pieces of metal. As you can see here in this picture, two metal are going to be welded with the help of the laser beam. Laser beam is This laser beam have high energy, and due to this high energy, heat will produce, and that heat will used to and it is used to fuse the metal. And when the metal fuse and solidify and form a proper weld joint. I will explain you what is laser. Actually, laser is stands for light, A for amplification, S for stimulated emission of radiation. And I will write here laser amplification by stimulated emission of radiation. I will explain with the help of the setup. Actually, laser is a monochromatic coherent light which is normally strike on the weld cavity between the two plates or the metal pieces. And due to this beam or laser beam, these two metals will be melted, and after some time, like only 3 seconds will be required to solidify the weld joint. I will explain this laser beam welding with the help of the this picture. Actually, this is the whole main or common setup of the laser beam welding. There is two flash lamps. Both are parallel to each other. Between the flash lamps, there is one ruby crystal tube. This ruby crystal tube is made up of the aluminum oxide with chromium metal. This chromium metal is reactive in nature. Both the flash lamps are connected with the capacitor. This capacitor has some charges. And this charge is provided to this power supply, and power supply will provide the current to both the flash lamps. This part of the flash lamp will get some charges from the capacitor, and this power supply will provide uh, the electric current to this flash lamp. These both the flash lamps has inert gas called xenon gas. Xenon is the inert gas. This xenon gas will use this electrical energy and convert this electrical energy into light energy, and this light energy is absorbed by the chromium atoms will absorb this energy. When the chromium atoms absorb this energy, they get excited. Actually, what happens in the laser beam welding and how the laser will form, light is the energy packets. Light contains the energy packet, and that energy packet is called photons. This chromium atoms will absorb these photons. And what exactly happen inside these excited atoms? As you know, there is nucleus, and outside the nucleus there are some energy levels. The orbit which is very close to the nucleus, it has a high energy electrons, and the atoms or the electrons which is in the last orbit, it has a high low energy. Atoms which is electron which is in the last orbit or away from the nucleus, it has that electrons has have low energy, and the electrons which is present in near the nucleus has high energy. When the photons are coming and strike with the chromium atoms, the chromium inside the chromium atoms, the electrons will start jumping. For example, this is low energy, this is high energy state. There is one electron, photons come and strike this electron. This electron will jump into the higher energy state and stay here for time 10 to the power minus 5 to 10 to the power minus 8 seconds. This state called meta stable state. Meta stable state, the electron will stay to 10 to the power minus 5 seconds to 10 to the power minus 8 seconds. Now it will come back. When it comes back during this process, when it jump from higher energy state to lower energy state, it will release one photon, and that photon will be in the form of red light. This photon is further strike with the other atoms, and it when it strikes to the other atom, the other atoms or when this photon emitted and by one excited atom hits another excited atoms, the second atoms gives off also a red light which is in phase with the colliding red light wave. And as you know, in the ruby crystal there are so many particles or atoms. uh, when all the photons strikes to each other or with the atoms in ruby crystal tube, there are abundant of protons will form inside this ruby laser or ruby crystal. Oh, this ruby crystal tube has two reflecting two mirrors. One is reflect 100% reflecting, the other is partially reflecting mirror. When this photon strike with the reflecting mirror, this 100% reflecting mirror is responsible to reflect all the photons and direct it, and it is responsible to direct all the photons towards the partially reflecting mirror. This partially reflecting mirror has small holes. It will allow to transmit some of the photons which is in the form of light towards the lens, and this lens is responsible to converge this laser beam. And when it converges, because conversion is very important, because this beam, it has to strike, or it has to focus into the weld cavity. This is the weld cavity. Because if it is not converge, or if it doesn't converge, or it will disperse into the environment, we cannot form a proper weld joint here. This is the most common type of welding. Normally, Rolex and switch watches, sharp small gears are welded with the help of the laser beam welding. Laser beam welding is expensive welding. So um, tiny small cavities can be welded with the help of the laser beam welding. I've explained you how the laser forms, because laser is formed due to these excited atoms, and with the help of these photons, because the photon contains the packed energy. And normally, most of the scientists call these photons packet of energy, and when it releases in the form of light, and it will form inside this tube in abundant form. Number of photons will be formed inside this tube, and when it strikes to the reflecting mirror, or this 100% reflecting mirror is responsible to direct all the, or to reflect all the photons towards the partially reflecting mirror. And partially reflecting mirror has small holes, and from this holes, this beam will go towards the lens, and this lens is used to converge the laser beam into the weld cavity. When it strikes with the weld cavity, it contains high energy and is traveling with the high speed, so it contains the high energy, and due to high energy, heat will produce during the collision, or during the when it strikes to the workpiece. Heat it will produce, and that heat is used to fuse the base to these metals. And after 2 to 3 seconds, this molten metal solidify and form a strong weld joint.